Hi, and welcome to AppSecCon 2022. We're about to kick off the session, AppSec 101, the what's, whys, and hows of application security. This is by Jennifer McLarnon, Senior Manager of Security Consulting at Accenture. A great session, whether or not you're starting out in application security or you've got a program that you're trying to mature. Let's go ahead and see what Jennifer has to say.
Good morning, and thank you for joining AppSecCon. In this session, AppSec 101, what, why, and how of application security, we will review what application security is and how it integrates with traditional security practices, why it's critical in modern software development teams, and how to roll out across your organization, leveraging people, process, and technology correctly. My name is Jennifer McLarnon. I work for Accenture as a security consulting senior manager, and am the public service client group security lead for the Northeast. I support our client group teams working with state and local governments, municipalities, quasi-state agencies, higher ed institutions, and nonprofit organizations. I see myself as a security generalist and love to look at security holistically. I enjoy working at Accenture, its culture, and as the largest security firm on the planet, I am fortunate to call upon my security peers and their great depth and breadth of security knowledge and deep industry expertise. I also work at Assumption University as an adjunct cybersecurity instructor, and I'm very grateful for the opportunity to participate in today's program, and thankful you have joined this session, and hope that it helps you as you navigate along your AppSec journey. For years now, we have been told by the experts that security is a business issue, not an IT issue, and also that every company is now a technology company. And certainly COVID has led to rapid digital transformation, and as a result has increased the attack landscape. Organizations are accelerating their app development using Agile and DevOps, and apps are great. They help organizations enhance their customer experiences and generate revenues. But as we know, threat actors are taking note. And MITRE lists the techniques of at least 20 different threat adversaries used to exploit public-facing applications. These applications are potential gateways to other parts of the network that might expose access to an organization's sensitive data, intellectual property, and can be a treasure trove of information in and of themselves, often containing PII or financial data. If the application is hosted on cloud-based infrastructure or is containerized, then exploiting it might have a trickle-down effect and lead to that container being compromised, or can allow the threat actor to access the cloud or container APIs, or even take advantage of weak identity and access management policies. To review some of the risks to most software applications, that would include data leakage and exposure due to improperly protected data, injection of malicious code, software that has not been tested that contains vulnerabilities that can be exploited by hackers, mis or unconfigured security controls, misconfigured authentication and session management, lack of logging and monitoring, and failing to consider security during the planning stage. The OWASP Foundation also publishes the OWASP Top 10 Web Application Security Risks and is a standard awareness document for developers in web application security. According to their website, they represent a broad consensus about the most critical security risks to web applications and is globally recognized by developers as the first step towards more secure coding. Application security professionals use a variety of tactics and techniques for app security specific to the app itself and its specific use case. Application security includes the use of app security testing tools and controls to remove weaknesses and vulnerabilities from the app as it is developed, including access control safeguards that prevent unauthorized access to applications or the hijacking of authenticated accounts, authentication and authorization controls to ensure the validity of users, encryption controls to protect data at rest inside the app, or the use of AppSec to encrypt data being sent to and from the app. Logging controls to track activities and exposure for the testing performance, preventative controls like security testing, corrective controls that terminate malicious activity, or patching software to eliminate vulnerabilities, as well as detective controls like IDPS and antivirus scanners. As I mentioned earlier, I consider myself a security generalist and enjoy looking at my client's security landscape holistically. I very much consider myself a people person as well, and am very relationship driven. Throughout my career, which actually began as a science teacher, I would often ask myself when planning a lesson What is the objective? What do I want students to know and to be able to do when we are done? That helped focus on the what, the why, and the how. I was also hyper-focused on the misconceptions that they brought with them to the lesson and those that they developed during it. That required frequent check-ins to clarify misconceptions and to redirect. Early on in my teaching career, I discovered that providing timely, specific feedback to students and explaining what they are doing correctly and incorrectly, but focusing on what they are doing right, is especially critical and essential to their learning. Similarly, specific feedback highlighting how each learning outcome was meeting a targeted, wider goal was critical to the overall success of the learner. When I transitioned into IT, I found that the experiences I had with my students creating lessons, clarifying misconceptions, and providing feedback helped ground decision-making and led to collaborative pursuits with members of the business units. I often found the best initial question to ask to be, why are we doing this? What is the objective? What do we want to know? Or often, what do we need to know? And what do we want to be able to do? Often IT or security didn't own those answers, right? Which led to engagement with the business units. So when I think about application security, the process of protecting computer applications from external security threats, including identifying, prioritizing, and remediating, I immediately get a visual of a conference room table populated by different members of the organization, and definitely not one of a lone programming team siloed off from the rest of the group. It, like the overall security program, is an all hands on deck type of endeavor. When thinking about rolling out an application security program at your organization, it can be a bit overwhelming, and often the first step can be a tricky one. I think sometimes it's called analysis paralysis, the state of overthinking or overanalyzing a decision so one is delayed or never taken. And I'm not judging anyone, and I've definitely been there. It can feel like an overwhelming task with many moving parts, processes, and people. Often a CISO or security team can feel powerless. I think that with most initiatives within an organization, it starts at the top. Leadership sets the tone and is ultimately responsible for the success of any application security program. They can champion the program, they can fund the program, provide the necessary technology and staffing, and spend time thinking creatively about what is needed to ensure its success. Although it is very much a collaborative effort between the security teams and the DevOps teams, a successful implementation requires putting someone or a team in charge of overseeing it, and leadership needs to make it a priority. I think that it's best if it's a collaborative effort between the security teams and the DevOps teams. Just as students have misconceptions, so do members of each group, as often they have operated in isolation. It's important for leadership to recognize this and to make an effort to bring individuals to the table in conversations that are skilled communicators and, dare I say, have a lot of emotional intelligence. They should have the vision to see how their collaboration is essential to the overall success of the organization, and they should be willing to engage with folks on each side, to dig deep into technical configurations without fear of judgment or criticism. For the most part, I think the research shows that developers don't view security as their main function, but they do expect leadership to set expectations for them to follow, including training, access to testing tools and frameworks from which to work in. Security teams should also work on expanding their knowledge of programming languages and how apps are built, tested, and developed so that they can have more meaningful conversations. Security teams can help teach the developers to think like attackers. They can participate in red team exercises together and collaborate and celebrate security champions in the developer ranks. I imagine that many CISOs feel like paper tigers when it comes to ensuring DevOps security. Often DevOps programs are well established, perhaps even began without any governance or security standards or frameworks in place. And although CISOs are eager to engage with the DevOps teams, they may not have the authority or means to start that conversation without fear of friction. They may have stammered or frustrated DevOps teams in the past by delaying development at the end of the development cycle. AppSec teams need to keep up with the speed of modern development teams. Although every organization is different in size, complexity, and each have unique business goals, I think that they all want to go fast. Speed is essential for staying ahead of the competition, and security, if done correctly, can help organizations go faster. And as organizations, we care about the confidentiality, integrity, and availability of our systems and data. We can all agree on this, and this is the message that CISOs might want to send to leadership. If you are just getting started with application security, The secure development lifecycle can help. The cycle incorporates security into all stages of the life cycle: the planning, design, build, release, maintenance, and updates, as well as the replacement and retirement of the app. Collaborative planning is key to project alignment, involves the engagement of dev teams and project managers with security and operations. The SSDLC framework examples include NIST Secure Software Development Framework, as well as Microsoft Security Development Lifecycle. NIST provides a framework and includes documents that outline and prescribe standards, guidelines, and software development practices, including providing secure coding training to developers to ensure security from the start, automating and integrating security tests to detect security risks as close to the point of remediation as possible, and securing open source components and libraries present within the projects. Microsoft also offers consulting services, as does Accenture, shameless plug, to support all phases of your application security journey. And you can even outsource your application security to Accenture to manage it for you. Outsourcing may help you scale or add value, and perhaps it may even be more affordable. It can be a challenge to marry GRC, scaling, and modernizing all at once. Just some food for thought. Anyway, according to NIST, their secure software development framework is to reduce the number of vulnerabilities in software released to production environments, as well as the mitigation of the impact of potential exploitation of unaddressed and undetected vulnerabilities. The framework also helps address root causes and prevents future reoccurrences of vulnerabilities. According to NIST, the SSDF can help an organization align and prioritize their secure software development activities with its business and mission requirements, risk tolerance, and resources. The SSDF's practices are outcome-based. Comparing the outcomes an organization is currently achieving to the SSDF's practices may reveal gaps to be addressed. An action plan to address these gaps can aid in setting priorities that take into consideration the organization's mission and business needs and its risk management processes. In addition to risk factors such as cost, feasibility, and applicability should be considered when deciding which SSDF practices to use and how much time and resources to devote to each practice. Automatability is an important factor to consider, especially for implementing practices at scale. Also, some practices are more advanced than others and have dependencies on certain foundational practices already being in place. The SSDF's practices, tasks, and implementation examples represent a starting point to consider. They are meant to be changed and customized and to evolve over time. The intention of the SSDF is not to create a checklist to follow, but instead to provide a basis for planning and implementing a risk-based approach to adopting secure software development practices and continuously improving software development. According to Microsoft, the Microsoft SDL introduces security and privacy considerations throughout all phases of the development process, helping developers build highly secure software, address security compliance requirements, and reduce development costs. The guidance, best practices, tools, and processes in the Microsoft SDL are practices Microsoft has used internally to help build more secure products and services. Since first shared in 2008, they've updated the processes and practices as a result of their growing experience with new scenarios such as the cloud, Internet of Things, and artificial intelligence. OWASP, the Open Web App Security Project, also urges companies to adopt their top 10 web application security risks document to start the process of ensuring that their web applications minimize the risks outlined. And I believe, and I happen to agree, that using OWASP top 10 is perhaps one of the most effective first steps towards changing the software development culture within your organization into one that produces more secure code. Ideally, organizations should secure each phase of the SDLC in the most appropriate manner for their stakeholders and contexts, while also ensuring that each security measure facilitates security practices across the whole project. The secure software development lifecycle combines applying best security practices with functional aspects of development to secure the dev environment. It moves tasks such as testing, security, or development earlier in the application dev cycle, often referred to as shifting left. Most importantly, it is a change in the mindset and holds both groups accountable and promotes shared responsibility. Integrating security into every step of the process is critical to workflow and ensures the acceleration and speed of development. And just as feedback is important to learners, security feedback is critical to developers and ensures fewer errors in the deployment phase and reduced costs associated with release delays and data loss and breaches impacting end users. Automation tools are critical to DevSecOps as well. In order to keep up with the fast-paced DevOps environment, security must be automated and integrated with a continuous integration and continuous delivery pipeline. Tools that detect and fix vulnerabilities and use of continuous scanning help the security teams oversee security without a manual review of every release. Tools include static application security testing, dynamic application security testing, interactive application security testing, as well as web application firewalls. Application security testing should be done at all phases of the application development. SaaS testing helps developers catch common flaws before a build is compiled. A development team might use many SaaS tools to support various languages or development platforms. Static application security testing, SaaS, is a program designed to analyze application source code to find security vulnerabilities or weaknesses that may open an app up to a malicious attack. Software developers have been using SaaS for years to find and fix flaws in app source code early in the software development lifecycle before the final release of the app. DAST enables security testing experts to probe a running app to identify problems with configuration, error processing, and application inputs and outputs. SAST and DAST are regularly used in tandem. Dynamic application security testing is a program used by developers to analyze a web application while in runtime to identify security vulnerabilities or weaknesses. Using DAST, a tester examines an application while it's working and attempts to attack it as a hacker might. DAST tools provide beneficial information to developers about how the app behaves, allowing them to identify where a hacker might be able to stage an attack in order to figure out how to mitigate the threat. Interactive application testing, IaaS, combines SaaS and DAST techniques and uses the best benefits of both technologies. Application security is a component of an overall information security program that includes policies, procedures, incident response, and disaster recovery. The same can be said of network security, and the two have similarities. Regardless of the specific threats and vulnerabilities associated with network systems and application environments, both network and application security are in service to the overall business needs and seek to mitigate IT risk. You need to know your assets, their weaknesses, and have the ability to prioritize and remediate vulnerabilities. They are both part of a wider risk management program, and it's great if you have metrics to quantify and measure your performance, especially the number of vulnerabilities, the severity, and the days to resolve. We need to think about CIA, right? Encryption of sensitive data, integrity, and what can be secured over the network or using hash values, TLS security, or digital signatures. Network security and application security strategies both seek to understand the environment, the weaknesses in each, and both need appropriate visibility and controls in place to minimize the chances of a security event. Threat modeling helps define your enterprise assets, the purpose of each application, their security profile, in order to prioritize potential threats and countermeasures that could affect your application. Threat modeling can be used to shape an application's design to meet your company's security objectives and reduce risk. Just as you'd inventory your crown jewels, data, and processes, application security best practices include mapping out all of your applications, the threats to them, how an attack could be carried out, and how that could impact the app, the organization, and the user. And just as security professionals are in an evolutionary arms race with threat actors, they also need to keep pace with the app developers and their reliance on automation, machine learning, and AI. Security teams need to keep pace with tools of our own, especially tools and platforms that enable application security teams to scale their ability to successfully identify, remediate, and prevent, as well as identify and eliminate gaps in coverage. Lastly, in addition to tools, executive sponsorship and genuine collaboration between security operations and developers is key. People need to communicate, share their ideas and expertise in pursuit of common business goals. That's all I have for today. I thank you for your participation and best of luck in your app security endeavors.